And assuming this is 45 degrees, this is also 3 and 3 in meters. So how we find the collapse load? We write internal work for all the elements and say for element 1, internal work is equal to length of projection of the yield line for element 1 onto the axis of rotation of element 1. So this length of projection is here simply 6 meters, times the moment of resistance of reinforcement, MP, times the angle of rotation of element 1. If this crack pattern is in the slab, then the maximum displacements are at these points. This is where the slab deflects the most. And so these points all deflect by delta. And then the angle of rotation of element 1 is this delta divided by 3 meters. And if we know that moment of resistance, say, is 20 kilonewton meter per meter width, then we can find the internal work as 2 times 20 delta, so it's 40 delta. This is for element 1. For element 1 dash, it's exactly the same. For element 2, internal work will be the projection of the whole yield line, so that's 10 meters, times moment of resistance of reinforcement, times delta over, again this is 3 meters. So the angle of rotation this is now 3.3 times 20, so it's 66.7 delta. And the total internal work, and for element 2 dash is exactly the same. So the total internal work is 40 delta times 2 plus 66.6 delta times 2, and that is 130 and 80, 213 delta. So that is the internal work.